Welcome back, dear students. In video 1, we discuss some shortcuts related to the points, and in this video, we are continuing with the topic. And today we will discuss more shortcuts related to the points. The topic is a straight line. If you want to see the previous shortcuts, you can go to my video 1. I will give the link in my description. And today we are going to discuss the point 6. We already discussed 5 shortcuts. Now the shortcut 6 is, suppose we have an equilateral triangle whose any two vertices is known. Suppose ABC. A is known, x1 comma y1, and vertex B is x2 comma y2. We have to find the vertex C. So we can obviously find this vertex with the different methods, but if you use different methods, it will take some time to find the vertices. There are 2 vertices possible, which will make it an equilateral triangle. So I am just writing the result, so you can save the time using that result. What is that result? It is same as the right angle isosceles triangle. Almost same result is there. So the coordinate of the third vertex, we can write sum of abscissa plus minus root 3 times difference of ordinate upon 2, comma sum of ordinate minus plus root 3 times difference of abscissa upon 2. So if you have any 2 vertex of an equilateral triangle is known, we can find the third vertex. You need to choose 2 combination, first plus, then minus and then plus. So you can see that it is almost same formula as the we used in the right angle isosceles triangle. Now let's move to the next point, 7th. In this point, if we have equation of sides of a parallelogram is known, suppose this is a parallelogram, and we have equation of sides of a parallelogram is known, let it be a1x plus b1y plus c1 equal to 0, and opposite side is a1x plus b1y plus c2 equal to 0. Let this side is a2x plus b2y plus c2 equal to 0, and a2x plus b2y plus d2 equal to 0. We have to find area of the parallelogram if equation of sides is known. So what is the formula for this? Area of that parallelogram is given by modulus of c1 minus c2 into d1 minus d2 upon a1 b1 a2 b2. Finally, what is the value? It is c1 minus c2. It is difference. You can see what is c1 minus c2 is the difference of the constant term of the parallel lines, and this is d1 minus d2, and in the denominator it is a determinant, and whose value is a1 b2 minus b1 a2. This is the area of a parallelogram. We can remember when equation of sides is known. Obviously there are different methods, but if you remember this formula, you can find area of the parallelogram easily when equation of sides is known. And there is one PYQ, previous year question of IIT-JEE, based on this formula. Let me discuss that example also. Question was, find area of parallelogram whose equation of sides are given by, it is y equal to mx, y is equal to mx plus 1, y is equal to mx, and y is equal to nx plus 1. We have to find area of the parallelogram. So to find area of the parallelogram, we can use this formula, which is what? This is area is equal to, take a determinant, and difference of the constant term, which is 1 minus 0, and again 1 minus 0, and this is the 2 into 2 order determinant, which is m comma 1 n comma 1. So finally area is 1 of mod of m minus n. So this is the area of the parallelogram whose equation of sides is known. We can find easily area of the parallelogram if equation of sides is known using the previous formula. Now let's move to the next point. It's point number 8. What is that? Area of a triangle whose equation of sides is known. Obviously we can find area of a triangle. If sides, equation of sides is known, we can find vertices of the triangle ABC, and then we can find area using area of the triangle. But I am here writing different formula for the area. It is what? Area is 1 upon 2 C1, C2, C3 A1, B1, C1 A2, B2, C2 A3, B3, C3. Obviously there is a use of determinant in this formula. If you are in class 11th, you can skip this result, but if you are in class 12th or you are from dropper batch, you can remember this formula. And what is C1, C2, C3? Actually here equation of lines are A1x plus B1y plus C1 equal to 0, A2x plus B2y plus C2 equal to 0, and A3x plus B3y plus C3 equal to 0. And this capital C1, C2, C3, this is capital C1, C2, C3, and this capital C1, C2, C3 are cofactor of small c1, c2, c3. So as I told you that this formula can be used by class 12th and dropper students, because in class 11th we don't know about cofactor minor. So for class 11th student they can skip this result, but till point 1 to 7 it is important. Now next move to the next point. The next point is a formula for transformation of x's. Obviously we have formula for transformation of x's, but how to remember this formula? Sometimes it skips from the mind. To remember that formula, first let me write the formula. What is rotation? As we know, there is a coordinate axis. If you rotate the coordinate axis by some angle theta, and if the old system, the coordinate is, suppose A is a point whose coordinate is x comma y. This is according to old system, and according to new system it is capital X comma capital Y. If you rotate the axis by an angle theta, so if you already go through the topic, we know the relation. What is the relation? Relation is x is equal to capital X cos theta minus capital Y sin theta, and small y is equal to capital X sin theta plus capital Y cos theta. You can remember this result directly. Otherwise you can use this complex number also. If you want old system in terms of new system, then you can write small z is equal to capital Z e to the power I theta. What is small z? It is small x plus iy, and it is capital X plus iy, and e to the power I theta is nothing but cos theta plus iota sin theta. Now if you equate real and imaginary part of these two complex number, you will get the same result, this. So we need to remember this small z is equal to capital Z e to the power I theta, And if you want new system in terms of old, you can simply write capital Z is equal to small z e की power minus I theta. So this one is capital Z and this is small z. So we can remember how to convert, how to relate old system, new system and theta using these two formula. Now let's move to the next point. Now next point we will discuss one question in which there is a shortcut is going to be used. Let me write the question first. It is again a P by Q. Let me write the question. What is the question? In an acute triangle ABC, the base BC has its equation four x minus 3y plus 3 equal to 0 if the equation if the coordinates of orthocenter, you can write it as H, and circumcenter, let it be E, of triangle R 1, 2 and 2, 3 respectively, then radius of the circle circumscribing the triangle is root m upon n, where m and n are relatively prime. Find m plus n. Now, how to solve this question? So we have a acute angle triangle ABC. Let me draw the figure. Suppose we have this triangle. Suppose we have this circle, and then we inscribe a triangle in it. So this is the triangle ABC. What is given in this question? In an acute triangle ABC, the base BC has the equation. We have equation of this BC. If the coordinate of coordinate of orthocenter is known, and coordinate of circumcenter is also known, let it be the circumcenter. The radius of the circle circumscribing the triangle, that means we have to find the radius of this circle. So to solve this question, we have one result, that is the point 10, or you can say the shortcut number 10. Let me write that shortcut first. This is very important result that we should remember. What is that result? The image of orthocenter from side of the triangle lies on its circumcircle. So IIT-JEE asked this question. If you know this result, this question will become very easy, since we know that the image of the orthocenter from the side of the triangle, from any side of the triangle, lies on the circumcircle. So we have already this H orthocenter is known, equation of BC is also known. So if you take image of H from the BC, suppose image is H dash, it will lies on the circumcircle BC. So we have to find circumradius, or you can say radius of the circle. So if H dash, you can find this H dash. If H is known, you can find image of H from the side BC, is equation of side is known. So you will get the H dash. Now if H dash is known and P is known, P is what? Circumcenter, and H is on the circle. So you just have to use distance formula to find pH. So you can find pH easily. Just use distance formula. And I'm expecting that you know the formula for image of the point from a line. So you can find image of the point H from the line as equation of line is given. So you get the point H dash, then you can find pH easily because P is already given. So I am not writing all the formulas here. My purpose for this video is just I am giving some shortcuts related to the straight line. In this video I discuss another 5 shortcuts. In the next video I will discuss more shortcuts related to straight line. So this is a P by Q. This is also an important question and an important result. You can use this result. So that's all for this video. Soon I will upload the third video and give some another shortcuts related to the straight line. Thank you for watching this video.